Howdy, I'm Hema Kedan, environmental engineer and scientist, and today my presentation is on hazardous waste. The topics that we'll cover are first a look at the US laws and the international treaties. This will help us come to a definition of what is hazardous waste. We'll look at some examples, how much and where is it produced, treatment and management options, followed by a look at household hazardous waste and a conclusion. So the three main important US laws, the first one is the Resource Conservation and Recovery Act, RCRA, enacted in 1976. This law provides a framework for identifying, treating, transporting, and disposing of hazardous waste based on a life cycle approach, that is, from the cradle to grave approach. The point of generation here is the cradle, and the point of disposal is the grave. The second important law is the Comprehensive Environmental Response, Compensation and Liability Act, also called the CERCLA, enacted in 1980. This law is also called the Superfund Act. It is regulated by the EPA. The objective of this law is to identify sites that have been heavily contaminated by hazardous waste, and it also provides the funds needed to clean up. One of such example of such sites is the Love Canal. It was used by the community and a company to dump all their hazardous waste, and later a school was built on that, and we started to find that the children were getting sick, and they discovered that there were lots of hazardous waste. So this law helps to identify and clean up those sites. Another important law is the Toxic Substances Control Act, enacted in 1976. It is administered by the EPA, and it regulates the introduction of new or existing or new chemicals on the market. So if ever a company wants to introduce a new chemicals, they have to inform the EPA and get the formal approval before they can do so. On an international platform, one of the most important treaty is the Basel Convention. This was proposed in 1992. This law controls the transboundary movements of hazardous waste from one country to another. Basically, it bans participating countries from shipping hazardous waste to other countries without their permission. And if permission is given, this transfer has to be done within very established standards. The objective here is to prevent illegal transfers of hazardous waste from industrialized countries to developing countries who are ready to accept hazardous waste at the expense of the environment. This treaty has been signed and ratified. By ratify, we mean formally approved and implemented by 183 countries in the world. This treaty has been signed by the US but not ratified. It means that the US does not have the obligation to implement it. The second important international treaty is the Stockholm Convention on Persistent Organic Pollutants, also called POPs. These regulate the use of 12 widely used persistent organic pollutants that bioaccumulate in humans and animals. So by persistent, we mean that the POPs, these chemicals, they do not degrade, but rather they live on in nature, and they can be transported over very long distances by wind and water to all around the world. Now, by not degrading also, these chemicals, they bioaccumulate in humans and animals, meaning that they are found in lower levels in small animals, but as you go along the food chain, the toxic level increases in higher animals. The dirty dozens, how it's called, includes DDT, 8 other chlorine-containing persistent pesticides, polychlorinated biphenyls, which we know as PCBs, dioxins, and furans. This treaty has been signed and ratified by 179 countries, and again, it has been signed by the US but not ratified. Now, this brings us to a definition of hazardous waste. According to the Resource Conservation and Recovery Act, the RCRA, it is any solid, liquid, or gas that may cause or significantly contribute to an increase in mortality or an increase in serious irreversible or incapacitating reversible illness. Also, it can pose a substantial present or potential hazard to human health or the environment when when improperly treated, stored, transported, or disposed of, or otherwise managed. Now, the four main characteristics of a hazardous waste are: first, is it ignitable? It means, will it burn? And these are the symbols of the when ignitable waste. Secondly, is it corrosive? Will it eat through a container? Thirdly, is it reactive? It means, will it explode? And lastly, is it toxic? That is it poisonous? Is it going to harm a person? Will it kill you or kill organisms in nature? So we have already looked at the characteristics of hazardous waste. Now let's see how much of it is produced. This chart shows the production on a worldwide level. So the darker the red color, the more the production of hazardous waste. As you can see on this chart, the country with the highest production is Russia, with around 139 million tons produced per year. The red countries is the US, which produces around 30 to 37 million tons of hazardous waste per year. And the orange countries, Brazil, China, and Saudi Arabia, produces around 11 million tons per year. So, in the local context, the US produces around 20 to 30 million tons annually. Most of this is sent to underground injection, 90 to 96%. Landfill is around 4 to 10%, and land applications is less than 0.4%. On a household level, the average US production is around 30 pounds per year. So this chart again shows the amount that is generated in the US and how it is treated. So on the very left side, you would see from the year 2001 to 2015, it is almost 30 million tons, a little less than 30 million tons produced annually. Very little of it are stored. Some of them are sent for material recovery, some for energy recovery. A little bit is treated, and most of it on your right hand side shows a chart of how much is disposed. So most of the waste generated are eventually disposed. This shows how is it disposed to land. So underground injection, like we just said, most of it is injected underground. Now, who are the major producers of hazardous waste? This table gives just a few of them. These are considered to be the main producers. These are chemical manufacturers, printing industry, petroleum refining industry, leather product manufacturing, paper industry, construction industry, and metal manufacturing. The right side of the table gives you example of the type of hazardous waste that are produced. Aside from these major producers, there are also small producers, and this would be household and things like car repairs, workshops. Now, the EPA has provided a framework that enables manufacturers of hazardous waste first to be able to identify whether the waste fall into the category of being a hazardous waste. Now, this is a yes and no chart. So if you answer those questions, the generators are able to identify. So first of all, is the material solid? Second, is it excluded from the list of definition of hazardous waste? If it no, then is it a listed characteristics? If it continues to be yes, so is the waste delisted, that is not on the list? If no, then the waste is definitely hazardous and subjected to the RCRA Act. So once you have identified that the waste is hazardous in nature, the waste generator is responsible to transport that waste, properly label that waste, transport it, make sure it is properly recycled, treated, or disposed of. So this is the cradle-to-grave approach. Now, how do we treat hazardous waste? This has been proposed by the National Academy of Sciences. This is an ideal scenario. So the first level is produce less of the waste. How do we do so? By first maybe changing the industrial processes to produce or eliminate hazardous waste production, reuse and recycle as much as we can. On a second level is to convert the waste, once it's been produced, to less hazardous substances. This can be done by natural decomposition, incineration, thermal treatment, chemical, biological, and physical treatment, or dilution in the air. Whatever waste cannot be treated and what remains at the end of these first two steps are put in perpetual storage. These can be landfill, underground injection wells, surface impoundments, or underground salt formations. So the method of treating hazardous waste, the first one is physical method. So it basically uses a physical compound. It can be charcoal or resin, or a distilling liquid that is used to filter out the hazardous fraction from the non-hazardous fraction. And the hazardous fraction can further be encapsulated in glass, cement, or ceramics. The second type of treatment is chemical methods. It uses chemical reactions to convert hazardous waste to less hazardous chemicals. For example, the use of cyclodextrin, a type of sugar made from cornstarch, to remove toxic chemicals such as solvents and pesticides from contaminated soil and groundwater. Bioremediation, as the name suggests, uses bacteria and enzymes to help destroy the toxic or hazardous substances. For example, the treatment of sites contaminated by chemicals such as PCBs, pesticides, and oil. It leaves behind a less harmless substance such as water and soluble compounds. The bioremediation brought about by bacteria and enzymes, they take longer, but then they cost less. Phytoremediation is a biological method that uses natural or genetically engineered plants, which is called pollution sponges, and the plant absorb, filter, remove contaminants from polluted soil and water. They can be used to clean up soil and water contaminated with pesticides, organic solvents, radioactive or toxic metals. Incineration. It is used to convert the compound to less harmful compounds. It does have the risk of air pollution there that can produce highly toxic dioxins. It produces a toxic ash that requires permanent storage. One of such methods is plasma gasification, which uses electrical energy to convert trash to less harmful compounds in the absence of oxygen. This process produces a fuel gas that can be used to burn for energy. And it produces a glossy lumps of rock at the end. That is, it will not leach the toxic compounds. Now, the plasma incineration, the advantages, it produces a mixture of CO and H2, carbon monoxide, and hydrogen that can be used to burn to produce energy. It's mobile, easy to move to different sites. It produces no toxic ash. However, it incurs a high cost. It produces CO2 and CO. It can release particulates and chlorine gas, and it can vaporize at times and release toxic metals and radioactive elements. Now, storing hazardous waste. We have already looked at the treatment possibilities, physical, chemical, biological, and incineration. Now, those that cannot be treated, we proceed to the next level, which is storing the hazardous waste. One of this method of this is deep well injection, where liquid hazardous waste are pumped under high pressure into dry, porous underground rock formation far beneath aquifers. As you can see in the diagram, the hazardous waste is pumped way down below the aquifers. The advantages, it is safe if the sites are carefully chosen. The waste can often be retrieved. It is a low-cost process. Disadvantages, leaks can occur from corrosion of well casing. They can emit CO2 and other air pollutants, and this approach encourages waste production. It doesn't tell people to produce less. The other storing hazardous waste method is surface impoundments. It means storage of the hazardous waste in lined ponds, pits, or lagoons. As you can see in the diagram, there is a lining in a big pond, and the wastes are stored in that on the surface. The advantage, it is a low-cost process. The waste can often be retrieved. It can store waste indefinitely within secure double liners. The disadvantages, there can be leaking liners, and this will create water pollution. Being an open pond, if there is evaporation, it will emit volatile organic compounds which cause air pollution, and this approach encourages waste production rather than waste minimization. Now, the last one, for waste that we cannot really treat, very hazardous in nature, there is what we call the secure hazardous waste landfills. These have very thick and liner systems. So for highly toxic materials that cannot be destroyed, detoxified, or burned, these are buried in carefully designed and monitored landfills, and this is a very expensive and least used method. So lastly, we will look at household hazardous waste. So we don't really realize it, but household produces a lot of hazardous waste. As we saw earlier, around 30 pounds of hazardous waste are generated yearly by every household. So what are in our house that are toxic? This figure gives a few examples of it. Cleaning products, including disinfectants, drain, toilet, window cleaners, paint products, latex, oil-based paints, paint thinners, solvents, wood preservatives, etc. General waste like dry cell batteries, glues, and cements. Many of the gardening products that we use are also hazardous, such as pesticides, weed killers, ant and rodent killers, flea powders. Automotive products, gasoline, used motor oil, antifreeze, brake and transmission fluid, all of these are examples of hazardous waste that are generated by household. So what do we do about these? A few things that can be done is first avoid using waste that are really hazardous in nature, such as pesticides or other hazardous chemicals. And if we cannot avoid it, we use as less as we can. Also substitute harmful chemicals by less toxic ones, such as using vinegar to polish metals, clean surfaces and remove stains, baking soda to clean utensils and deodorize and remove stains. What we can also do is to not dump all our hazardous waste, pesticide, paints down the drain, but rather collect them and take them to a facility that can treat it for us. Most likely these services are free. So do not throw old bulbs, mercury products, batteries in the usual trash. Rather collect them and at the end take it to a facility that treat those waste. Conclusion. So how do we achieve a low waste society? So everything is connected. We cannot throw the waste and hope that it will not affect the environment. We cannot throw it and forget it. There's always a reaction. There's always an impact. So there is no way for the waste we produce. Dilution is not always a solution, but rather the best and simplest ways to deal with solid and hazardous waste are to reduce the amount we produce and prevent waste pollution. In an ideal situation, all the waste, we aim to become a zero waste society. That is, all the things that we use are biodegradable in nature. They can be disassembled and used again, or they can be sent back to the nutrient cycle by natural decomposition. With that, I thank you for your attention.